Okay, we're going to evaluate this integral, which is a definite integral, and our method is that we're going to use the fundamental theorem of calculus, part 2. All right, so here's our integral, which is a polynomial. So this is a very basic problem in terms of integration. And our first step for using the fundamental theorem of calculus is that we find the antiderivative. That's like, that's the first step, not the only step. Okay, so for x squared, we're going to use the power rule, which says that here's that 2 up here, x squared. You take the 2 and you add 1 and you get 3. And then you divide by 3. Then going on to the next one, we have this 2x to the 1 power. So you take the x to the 1 power and you add 1 plus 1 and you get 2 and you divide by 2. And then for a constant 4, the antiderivative is x. And sorry, it's negative 4x. So the derivative of negative 4x is 4. And then we don't write plus c. If we're doing an indefinite integral where we don't have bounds of integration, we write plus c, but we're not doing that here. And I made a mistake on that one of these. Okay, so it's x squared over 2. And let's see. So then I'm going to put in the bounds x equals 1 and x equals 3. So I draw a vertical line and I write 1 to 3. And then I go ahead and I plug in. And then it's pretty often the case that the simplifying is the more difficult part anyway. But so I'm going to put in 3 where x goes. And then I'll subtract where I put the lower bound in. And I put 1 where x is, where x goes. And okay. Oh, what did I do there? All right. Just trying to make it look a little neater. All right, so 3 to the third divided by 3 is 3 squared, which is 9. And then 3 squared is 9, and minus 4. Minus 1/3, 1 minus 4 is negative 3. So I have 9 plus 9 is 18. Minus 4 is 14. Minus 1/3 plus 3, distribute the negative. So 17 minus 1/3, that's 51 over 3 minus 1 over 3. So that's 50 over 3. Sort of wish I had the book I could quickly refer to make sure I did that right. I mean, especially the adding of the fractions and the last numbers. Does anybody have any comments on that, on whether they feel that was the right thing, or any questions? Okay. So
I just want to check. So for x, we plug in the 1 for the x equals 3 bound.
Oh, man. Thank you. So that's going to be minus 12 here. So 9 plus 9 is 18, minus 12 is 4. That makes 7 minus, so it's all wrong. Thank you so much. Okay, so we have 21 over 3 minus 1/3. So we get 20/3. Any questions about that, or any comments? Please tell me about putting the wrong thing in or wrong numbers, anything. Is that okay? Okay, the rest, so polynomials, as you can see, there's sometimes some, things like that where I make a mistake. But otherwise it's pretty straightforward. Let's do this other polynomial where, integrating a polynomial. For this guy here, what we really need to do is start by multiplying this, expanding this. And the way I do this is just using FOIL. So it's u times u is u squared, and then plus u times -3, and then I'll have 2u minus 2 times 3 is -6 du. I think I could have gone a little faster on that. And I go from 0 to 1. Now I'll integrate antiderivative. So I have u squared, I add 2 to 1, 2 plus 1 makes 3, and I divide by 3. Then I have, this is u to the 1 power, so I have u squared divided by 2 minus 6u. Okay, so what did I just do there, pretty quickly, maybe too fast, is I'm using the power rule. So I have u squared. I take the 2 and I add 1 and I get 3 now, and I divide by 3, etc. So the thing that made this problem just a little different from the one that we had before is that I first had to expand that that binomial, multiplication of two binomials. All right, all that stuff where I put in 0 is sort of overkill because you put in 0 and you get 0. So maybe just write down -0, but here I'll have 1/3 minus 1/2 minus 6. And so this will make, let's get a common denominator, 2/6 minus 3/6 minus 36 over 6. So that's going to be 2 minus 3 is -1. So I'm -30 minus 36 makes -37. Now the thing that I'm curious about is, does that make sense in terms of the idea? Well, okay, hold on. Let's just see what's going on. Is that I got a negative number, and so what I'm wondering is my function negative on the interval from 0 to 2? Well, from 0 to 2, u plus 2 is positive. U plus 2 is positive between 0 to 2, but u minus 3 is negative throughout the interval from 0 to 1. So 0 to 1, u plus 2 is positive, but u minus 3 is negative. And then, so a positive times a negative makes a negative. So the function is negative, I get a negative integral. Okay, we'll just do one more, number 29. So on number 29, there's a little bit of effort here. What we need to do is, when we have this sort of fractional expression, what we can do is we can break up this into two different fractions. And the reason that we're allowed to do this here is because the denominator, well, we can always do that breaking up the numerator, but why it's effective here, why it's going to lead to something, is that the denominator is a single term, a monomial. And so I'm just going to sort of stretch this out. I'm going to replace square root of x by x to the 1/2. So do you see, I'm not even at this point really doing any calculus. I'm simply rewriting this so that I have a sum of x to powers. So see, 2 over radical x is 2x to the minus 1/2 power, and x squared over radical x is x to the 3/2. And then I need to do that so that I can use the, I can use the power rule. Okay, so in this section so far, that's our main tool. Now, I have x to the minus 1/2 up here. It's x to the minus 1/2, x to the 3/2. Okay, I'm going to use the power rule. I add 1 to negative 1/2. Negative 1/2 plus 1 is negative 1/2 plus 2/2, and that makes x to the 1/2 power. And then I divide by 1/2. And then I have x to 3/2. I take 1 and I add to 3/2, and I get 5/2. And I divide by 5/2. And then I'll evaluate from 1 to 4. Before I do that, I think I'm going to, do that multiplying by the reciprocal. Okay, so I'll have 4. I'm going to put in the top number, the top bound 4. And then I'll have 4 to the 1/2, which is the square root of 4, plus 2/5. And I'll have 4 to the 5/2. I have 4 to the 5/2. Subtract 4, 2 times 2 is 4, 1 to the 1/2, plus 2/5 to the 5/2. Okay, so 4 to the 1/2 is 2 because it's the square root of 4 is 2. So I have 4 times 2. Then plus 2/5. Now the way to evaluate 4 to the 5/2 is, let's say without using a calculator, is you have 4 to the 1/2 to the 5th power. That's just how properties of exponents we can use. 4 to the 5/2 is 4 to the 1/2 to the 5th power. Now I'll distribute this negative when I subtract -4 minus 2/5. So we know that 4 to the 1/2 is 2, so that then becomes 2 to the 5th, and that part right there. So I'll have 8 plus 2/5 times 2 to the 5th was just 32, minus 4 minus 2/5. And then, well, I mean, eventually we can get this done, but what's the most efficient way? 8 minus 4 is 4. Then 2/5 times 32 minus 2/5 makes, I don't know. I had some idea I could do this in a quick way, but it's 2 times 32 is 64 minus 2. That's going to be 62 over 5. Okay, and then I'll write 4 as 20 over 5. All right, who will tell me where the mistake is in my adding fractions or whatever it happened to be? The idea, I think, was 100%, but there's always possibilities of mistakes putting things in. Anybody see any problems with this? So
don't think so.
Yeah, I think it's good. Just don't want to have to, put up if I don't want to put a wrong answer on a video. So okay, so let's just stop there. I'll zoom out so you can see that particular problem. So in this problem, it's still using the power rule, but we had to use algebra before we even integrated, just by breaking up this fraction into 2 different fractions, using really how we add fractions to do that, and then simplifying so we have powers of x. And then we use the power rule, plug in the top bound, the bottom bound, take the difference.